Now, number 42 is set up this way. This is number 42 from the homework. And it's one of the ones I flagged as a have to do it problems. We've got two circles. So here's the first circle is given. Second circle, we'll draw it over here. And there's a common tangent between them. So there's the common tangent. And that length is given as 12 units. The first circle has a radius of 5. Second circle has a radius of 2. And the question is, how long is this segment here? How long is that? So look at that and say, well, we had some rules. Rule 1 said, always figure out what you can do as far as radii go. So let's go ahead and write those in so we have them. That means this length over here is 5 and this length over here is 2. And there's still that gap between them. What's the other rule? Perpendicular. So all tangents should be drawn so that they're perpendicular, have them marked off perpendicular to the radius. So even if you don't quite draw it that way, you know there's a right angle there. There's a right angle up over here. And then the book also provides a hint. And they said, draw a line here that connects over to here. And that's the trick to these problems. What you want to do is imagine taking this 12 and sliding it down these two perpendicular and parallel rails, so that it lands there now. Right. When I've done that, I dropped it 2 units, so what's left?
So it'd be
3. Yeah. And now I'm solving this triangle. 3 here, 12 here, x here. X is the hypotenuse. It's a right triangle. So 3 squared plus 12 squared is equal to x squared. 9 plus 144, or x is the square root of 153. Now, I also mentioned you guys should be somewhat comfortable with simplifying radicals. You should be able to, at this phase of schooling, take the square root of 153 and be able to pull out perfect squares from it. My advice is always check to see if you can divide by 4 or by 9. Those will be the easiest to get in and out. And they're the ones that you'll see the most in the work. So this is really square root of 9 times 17, and that's why it's 3 root 17, which as a decimal approximate works out to be 12.37. Should I say more about that simplifying radical part?
What you mean, like the 9 point, or what you just
going from root 153 to 3 root 17.
Yeah, probably.
More on that, or?
Yeah.
Thing to remember is what you want to do is you're asking yourself, if all the perfect squares out there, so numbers like 4, 9, 16, 25, which of those divide into 153? And since 9 does, I can then factor 153 is 9 and 17, and then the square root of 9 is 3, so I can take the square root of 9. I've also seen students write it this way, square root of 9 times square root of 17, so they'll split it, and then they'll do it. Root 9 is 3, so there that is, and then that leaves root 17.
Oh.
So the simplified radical form answer is 3 root 17. The decimal approximate answer is 12.37.
So are you saying that 5, 9, 16, 25 can all go in the...
You want to check to see if they can. You always check perfect squares. So 2 is 2 squared, 9 is 3 squared, 16 is 4 squared, and so far up the line. Yeah. What more can I say about this fella?